Hi everyone, this is Bharti here. So in my previous session, I have explained about the linear regression intuition max loss function. So in this session, let's understand about the gradient descent. So gradient descent, it is one of the optimization algorithm used in ML. What is this optimization? Optimization determines which is the best parameters for our model. As we know, if the loss function value is less, the accuracy score of our model will be more. More or less, a gradient descent also strives to achieve the same result. So gradient descent, it is an optimization algorithm used for minimizing the loss function in various machine learning algorithms. It is basically used for updating the parameters of our learning model. So as we know, the equation for our linear regression, it is y is equal to mx plus c, where m represents the slope and c represents the intercept. So in order to calculate the parameters, we will be using y is equal to wx plus v, where w represents the slope and b represents the intercept. W weight and b bias. So here we have a model and we have trained our model and we have a 3 lines over here. So we need to find out which is the best fit line for our model. Let's consider this line as y is equal to w1 x plus v1, and this is as y is equal to w2 x plus b2, and middle line as y is equal to wx plus b3. So here, by looking at the figure, we can say this one is a best fit line and this is the best parameters. But here we have manually find it out. But when we try to plot the same thing in the gradient descent, how do we find out? So gradient descent something looks like this, the inward triangle, not exactly the triangle, opposite of the bell curve. So here in under y value we have the loss function, and under x value we have the weights. So let's randomly initiate some parameters to this gradient descent. So when we randomly initiate this value, we can see the y value is more. How did we find out? Because here we have initiated our parameters and it is very more. As we know, if the loss function is more, the accuracy score of our model will be more. We have to find out the less loss function. So in order to find out the less loss function, we have something called as a global minimum. So we have to find out this global minimum, but we have to reach over from there to here. How do we reach this? So in order to reach this, we have something called as a learning rate. So it is also one of the optimization algorithm that determines the step size at each iteration while moving towards the minimum of a loss function. So what is the step size? From this point to this point we are moving, so this is called as a step size. So from this point to this point we are moving, this is a step point. So in order to reach this global minimum point, we will be using this step size. So this global function, we will consider this one as a best parameters for your model. How do we consider it? Because here we can find out the y value for this global function is very less. As we know, the loss function, if it is less, then the accuracy score model will be more. We can calculate the parameters over here also, but it will be moving towards the high loss function. We have to find out the global minimum, that is less loss function, in order to get the higher accuracy score for our model. So let's get detail into it. Sorry, I forgot to explain. So here random value, that is how we have initiated. As I have explained in my previous videos, these are the parameters w1, w2, w3. So when these random values, it is w1 and w2. and this global minimum is W3 and B3, and that is how we found out that middle line is the best fit line for our model. So let's take an example. What are the chances of getting a person or a candidate getting admitted to a college? So we have some data set over here. So this admit will be a target column, and this 6 lines will be a future column. So we have this GRE, GPA, SC, SCS, SX, race and rank. So how do we find out these columns plays a vital role in getting admitted to the college? So this when we look out for the first candidates, the candidate score for GRE is 380, GPA is 3.61, SCS 1, male 1, race is 3, rank is 3, and the chances of getting admitted is 0. That means there is no chance of getting admitted. But when we consider the second person, GRA score is 660, which is high when compared to the first one. GP score is 3.67, which is high. There is a little bit of high. 0.6, yeah, 0.6 is high for the second candidate. SCS is 2, sex is female, race is 2, rank is 3, and the chance of getting admitted is more. But how do we consider it? Because GRE is more when considered the candidate 1. Let's go to the candidate 3. GRE score is 800, GPA is 4, SCS is 2, sex is male, race is 2, rank is 1, and chance of getting is also more. When we compare to the first candidate, third candidate GRA is more, GPA is more, and the rank is also 1. So there is a high chance of getting this third person admitted. Let's move to the fourth person. GRA 640, GPA 3.1, SCS 1, sex is male, race is 2, rank is 4. When we compare to the first candidate, the fourth candidate GRA is more. GPA is less when compared to the first candidate. SCS SES is 1, sex is male, race is 2, rank is 4. But when we consider this GRA score is more compared to the candidate 1, so the chances of getting admitted is more. Move on to the fifth candidate. GRA is 520 compared to the first person who has not selected. GRA is more. GPA is 2.93, wherein the first candidate, that the person who has not selected, GPA is more. SCS is 3, sex is female, race is 2, rank is 4. So compared to the first person, the rank is also more. I mean, it is very more. He has got the third rank, and this person has got fourth rank, and GPA is third person is 3.61 and this person is 2.93. GRE score is more, but the rank is very high. Means it is very high compared to the so the chances of getting the fifth person is also very less. Moving on to the last person, GRA 760, GPA is 3, SCS is 2, race, sex is female, race is 1, rank is 2, and the chance of getting is also more. So comparing these things, the first person or the fifth person, GRA score is more, GPA is less, but compared to the rank, this person has got the second rank. So here we will be considering the futures, we will be varying it, and we will try to find out what are the chances of getting admitted. So here this columns plays a vital role, as I said. So this GRE, GPA plays a vital role, but SCS, sex and race, it's not considering too much, and also rank also plays a vital role in the chance of getting admitted. So as I said, gradient descent is an optimization algorithm which is used for the minimizing the loss functions in various machine learning algorithm. It is used to find out which is the best fit model, best uh, used for updating the parameters of our learning model. So how do we calculate it? That is W is equal to W minus A into dW. That is initiated weight, new weight is equal to is initiated weight minus A into dW. So dW refers to the partial derivative of loss function with respect to m, that is the slope. The same function, but we have a changes over here. B is equal to B minus A into dB. So here dB represents the partial derivative of the loss function with with respect to c. So concluding this, so this is all about gradient descent. So in our next session, let's meet with hands-on theory part. Sorry, hands-on part. Thank you all.